Good morning. I've given you a minute or two to, well, a few minutes to work on this question, reviewing the chain rule. And as I mentioned earlier, but this is for video people, typically I do this as the third part of a three-part series on the chain rule. Hey, sorry. But I thought, oh, let's try and see if this actually works better if I do this second instead of third. So the chain rule, as you learned it the other day, if we're going to do the derivative with respect to x of f of g of x like this, it's equal to what? Oh, sure, now you're quiet. When I ask you a question, the question, what is this equal to? What is the derivative of this? How did it start? No. Yeah, d out Indian. There we go. So a d out was the derivative of the outside function. So that's the d out, and then the in is we keep the inside. And just because this is going to be on YouTube, I will say this was not my invention to call it d out Indian. So there's the in, the green part, and then the d in is derivative of the inside part. So my outside function here, thank you. When we find y prime, I'll do the derivative of the outside, bring down the 4, subtract 1 from the exponent. In doesn't change. And then dn, derivative of the inside, is 6x. So is this what you got? All right. So this is using Newton's notation, which is the prime symbols. We want to look at the chain rule using Leibnitz notation. And here's what it looks like. dy dx, well, maybe I'll just drag it out here, is equal to dy du times du dx. Where, stick with me here, we're thinking of y as being a function where u is the independent variable, and u is a function where x is the independent variable. So to do question number 1, using Leibniz's notation, this is how we would set it up. We would look at our outside function is u to the exponent 4, and the inside function u is equal to 3x squared plus 1. So we would find what is dy du. Well, we bring the 4 down in front, keep the u as it is, subtract 1 from the exponent, and there we go. And then we'd find du dx. And du dx is going to be 6x. So, nope, dy dx is equal to 4u cubed times 6x. But really the goal was to find the derivative of y equal 3x squared plus 1 to the exponent 4. And so what we do as our final step is we substitute, replace the u with the 3x squared plus 1, and then we get 6x. So exactly the same answer as we had from question number 1. Most of us prefer the strategy we did in number 1 because it's simpler. But we learn this largely because historically, it's good to know the history. And when we get into our next lesson, I'm going to require some dy dx notation. And so it sometimes helps us understand that. Okay, so we're going to work with this notation, but first we have a question.
How do you expand in the simplest form?
Well, often rather than expand it, I would want this in simplest factored form. So we just group the 4 and the 6x together to get 24x, 3x squared plus 1 cubed. So usually we'll want it in a factored form.
You don't want to expand it and that's not factored?
It's easier to factor first rather than expanding and factoring later. Okay, and looking ahead, the reason factored form is useful is because often we're going to be interested, where's the derivative equal to 0? To solve where something's equal to 0, if we can break it down to factored form, that'll often make it easier. Okay. Number 3. So this one is like a chain rule inside of a chain rule. Thank you. And so when we do the derivative of this part, we'll actually use Newton's version of the chain rule. And that'll be in combination with Leibniz's version of the chain rule. So I'll give you a head start on this. Okay, I have the derivative up there where I haven't replaced the u's with the 1 minus square root of x. Up to there, are we good? Yes. This is going to be more useful because I have this part of the question where it says my x value is going to be 9. And so 9 to the negative 1/2, my brain doesn't figure that out as quickly as if I have 1 over 2 times the square root of 9. So it's just going to be more useful.
It's not like mandatory.
Nope, not mandatory. Daniel?
Why did you do the chain rule again? Just like it's done?
You mean the black part? Okay. So up to this point, we're good? Okay. So now, because I want to know this derivative when x is equal to 9, I could replace all these u's with 1 minus the square root of x and then plug in 9. Or I could just calculate what is the value of u and x is 9. So that's going to be 1 minus square root of 9, 1 minus 3, which equals negative 2. So then I can substitute for the u a negative 2 and for the x a positive 9. And so I don't have to replace all the u's with a function of x. So this will be 3 times negative 2 squared plus negative 2 all squared. Two times negative 2. And then the 1 over, now let's go with negative 1 over 2 times the square root of 9. And then we can just evaluate. So again, this is telling me the slope of the tangent line where x is equal to 9 of this composition of functions. What's it work out to be? I don't know. 4 minus 2 is 2, squared is 4, times 3 is 12, times negative 3 is negative 36, times a negative is positive, divided by 2 is 18, divided by 3 is 6. Do you get 6?
Yes.
I have to push myself to do mental math just so I stay in practice. Did you also get 6? Yes, you actually did it. Actually did it and got 6. Okay, good. Questions? Oh, why, thank you. Math is beautiful. Okay, so next page, we have some check your understanding questions. So use this version of the chain rule to do these next few questions, please. 2 questions. Oh, yes. Okay, may I have your attention, please? Question number 4. I stopped at this point because I wanted to emphasize that what we're asked to find here is dy dx, which is the derivative of the y function with respect to x, which means x is the independent variable. So I don't want to stop here where I have u's. I want to go all the way till I replace all the u's so I only have x's. So our final answer would be questions with number 4? Good? Yes.
You have to expand it.
As in multiply the pieces together? We're not asked to, so we don't have to. Yes. Well, most simplified, we would, expand the 2 inside and then multiply the 2 brackets together. Yeah. We won't worry about that for that one. Number 5, I will just drag out my solution here and see if I got it right. Did you get a ridiculously big number?
Yep.
30,240? So this time I didn't replace the u's with x's. I just found when x is 1, what's the u, and the u's -2. Plug in the values, evaluate, dun, 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 and that's giving us the slope of the tangent line of this y function when x is equal to 1. So it's super steep. Oh, yes, quite. Okay, good with number 5. Yes. Yes. Question? Okay, number 6. We're going to differentiate and simplify the answers. Ooh, simplify, likely for this one is just going to mean factored form, because we don't want to expand the ridiculous thing we're going to get. But notice this time we don't have use y as a function of u and u as a function of x. So we need to choose how we're going to write it. So I would say y as a function of u is going to be u to the 99th. And then u as a function of x, 1 minus x over 3. Good? So we find dy du, which you tell me is u to the exponent 98. Yep. Du dx is going to be negative 1/3. So the u function is linear, right? And so we could just look at that. We have b plus mx. By m is a negative 1/3, right? So that's the slope of the tangent line. And then we want dy dx, which will be 99 u to the 98 times negative 1/3. But right away, I'm going to replace the u with 1 minus x over 3. And I'm not going to expand it, but I will multiply the negative 1/3 to get negative 33 minus x over 3 to the 98th. Good. Okay. Next page. So for this one, what I'm going to do, rather than using the quotient rule, is I'm going to think of this function as y equals 3, 5 minus x to the negative 1. And then I want to think of what's my outside function, y is a function of u, and my inside function, u is a function of x. Inside function, but what is it in terms of x? U equals 5 minus x. Yep. Which means my outside function is 3u to the negative 1. There we go. I'll let you find the derivative, and then I'll write up my answer. There's the answer I got for number 7. Is that what you got? Question?
Even as like your y, and you used to like 3 over x and 5 minus x, right? Or I mean 3 over u and then 5 minus x.
No, you can't leave u's and x's. You always have to replace the u's with x.
No, like I'm saying like you first said.
Oh, yep. Yep. And then eventually you want to replace the u's with a function of x. Did you have a question? Yep, that'd be okay. All right. The rest of this page is check your understanding. Some of you are already working on it. I'll give you a head start, and then I'll start pulling out my answers. There's my answer for number 8. The reason that I'm taking it all the way to the x, or I should say the 2 plus x to the 9th and the 2 minus x to the 9th, is because on your assignment, I'm going to expect that. So just pointing out that for the assignments, you know what I'm going to look for there. Otherwise, this one is normally fine. Oops, the one in the red box. Yes. I can't distribute the exponent 9.
Or could you just leave it as 2 plus x times 2 minus x all in brackets to exponent 9?
Oh, yeah, that would be fine too. Yep. Number 9, there's my answer. Any questions? Nine is good. And how are we doing with 10? Are we done 10? Some of us are done 10. Number 10, any questions? Yes. Do we have to rationalize the denominator? Often we'd say that simplest form, but at this point in math, simplest form can mean different things. So if you didn't rationalize the denominator, that's okay. Good. Yes. The square root of 32. We would say that that's not as simple as it could be. So typically we want a mixed radical. I was going to stop there, but we could probably look at that last page, which is this one. So once again, we'll give you some time to look ahead at this. And this page will help us understand why this is called the chain rule. Any questions with 11 or 12? No questions. So it's a matter of recognizing what's the outside function, inside function. 13 and 14, we have the composition of three functions. Sharia. Three functions. I'll give you a little bit more time. Oh. There we go. Okay. Here we have a composition of three functions. So we have an outermost function, a middle function, and an inside function. So this is why this is the chain rule, because we start with derivative of the outside function, bring down to 3, subtract 1, inside doesn't change. Yep. What negative? There is no -3. Look at your page. It's my square bracket that's making it look negative, but it's not. Okay, and we look to the middle function and say, what's the derivative of that? F prime, keep the inside function, oops, unchanged, which means it's an x. But wait, there's more. Derivative of the innermost function. And we've done this derivative enough that some of us can start to recognize, oh, that's going to be 1 over 2 root x. If you're not at that point, no worries. We just think of this as being x to the half, and then we bring down the half, subtract 1, and then this would be f prime of that. So notice, when we have a composition of three functions, there are 3 links in the chain that make up the derivative, which is why this is the chain rule. In general, for this last one, Sharia, I think you need to come sit up here. Okay. Maybe before I do this, I should rewrite it in the other notation. So this is the same as f of g of h of x. So it's just like number 13. No, up here. So when we find the derivative, derivative of the outermost function, inside is unchanged, times the derivative of the next layer in, inside is unchanged, times the derivative of the innermost function, h prime of x. We could have 5 functions in composition, and that would just add 5 links in the chain of derivatives being multiplied together. Good? Yep. Do you see how this is the derivative of x to the half? If we rewrite that as a radical, it'll be 1 over 2 root x. Okay. So You ready to try 15? Okay, I'll give you some time.
He heard you say, Brandon's right.
I did hear you.
You said, don't even lie, you heard me say.
Oh, sure, I heard you. Yep. But I was thinking about getting the video started again,
That's why you went all
but
back up.
I went all the way back up for the video. Yep. So we could keep going on this for a while, but I don't feel like it. Do you feel like it? Like this part inside here, because it's all in a cube root, so that's not all that pleasant when you have that cube root out there. So we're going to end up with fractions inside of fractions anyhow. So let's just stop and run away and say, good enough. Yes.
U plus 1 over U minus 1?
Oh, down here? Yes, it would. So that is definitely a candy. Good job. Okay, so when you look at the homework list, this is going to be the day 3 homework. So day 3 is the lesson we just did. And I kind of like doing it at this point. And then tomorrow we'll get into more complex combinations of power rule, quotient rule, chain rule, product rule, mix them all together in a beautiful soup. That'll be the end of today's lesson.